So just out of curiosity, like by raise of hands, has anyone here heard of Chartbeat before? Don't raise your hand if I just told you about it. Okay, so we got one person. That's actually more than I was expecting. So that's actually pretty good. But that's okay. Like it's not a product for you. So Chartbeat we do readership analytics for news publishers. So this is like a dashboard that shows how many people are on your website at any given time, and sort of each entry in that row is a news article, maybe an opinion piece or some sort of breaking news. And if you're on the editorial board of some big news publisher, you want to know what people on your website are reading and where they're coming from, if they're coming from email, Google, Facebook, Twitter, whatever. This is a slide that I stole from our marketing department. Presumably it's supposed to say that we're impressive. We work with some logos you may have seen, some news you may have read, a lot of page views, 6 continents. Turns out no news publishers in Antarctica. We've tried, but the sparse market. But so a lot of things being published. There's an example of a news article we're going to talk about a little bit in this talk. This says AMD closes a record chip deal with buying some company Xilinx, which is, an example of a typical news article you may have read. And if you think about this sort of going on this dashboard here, it would be some sort of entry that has the title of the page, saying how many people are on the page. But there's a lot more that goes into this article than just sort of the headline of the article. There's sort of primary people being referenced, AMD and Xilinx. There's secondary organizations like NVIDIA's referenced, even though they're not party to this specific event. They're referenced within the content of the article. And so this is a pipeline that I'm going to talk about today in my talk that tries to read through all of the content on this page. Yeah, take a photo. The slides will be online. It's okay. So we try to read through the content of this page and try and extract a lot more knowledge than just sort of the title and see what can we actually say about what's being discussed in this article. The idea being that we can go back to this dashboard and say, instead of sort of saying how many people are on one specific article, how many people are reading articles about this topic or that topic. So I'll start off sort of in the upper left-hand corner here. Is it left? Okay, it's definitely left, I think. In the upper left-hand corner, we have sort of a queuing system that comes in as we're sort of seeing new pages being published, and we have this consumer that reads messages from this message queue, and it just uses the regular Python requests package in order to go request the HTML just as you would, and if it's able to visit the page, it saves the HTML to S3 and pushes the URI in S3 along. And so what does this look like? This is an example of some HTML. If you ever go to a web page on your browser and right-click it and say View Source, this is what it looks like. This specifically is an example from a CNN article, which is maybe a little bit prettier than some examples you might see. There's some helpful metadata that's included along with the HTML. So there's sort of 3 different standards you can use, or at least that are sort of widely used. There's microdata, which is an HTML standard. Open Graph, Facebook uses to sort of get some idea of what's going on in the article in JSON LD. So if we go back to this example, if you maybe squint a little bit, I wasn't sure how big the projector would be when I made this slide, but if you sort of squint a little bit, you can see the meta name. Some of them start with sort of OG. So it says OG title, and that's the title of the article. OG description, and it includes a description about the article. OG image, and it has a link to sort of the headline image in the article. And some of them might include sort of the full body text as a metadata element in the article. But oftentimes they don't, and it's sort of a very difficult problem if you think about just looking at the HTML of a page and trying to figure out which text on the page is sort of the text you read and not sort of like a footer, maybe their privacy policy, cookies, or something like that. And so there are lots of different Python packages that will try to do this if you sort of give it some HTML document, try and figure out which text is actually the content of the page. You may have heard of them, a few different ones. We tried out a whole bunch of them. There are lots of different comparison and benchmarks online. So if you try to find like sort of the best package to do it, lots of people have published scoring methodologies. This one I thought was particularly special. So I included in my talk. This one is a software vendor who sells a software product called AutoExtract, and they sort of published a benchmark comparing themselves to a bunch of open source solutions, and sort of unsurprisingly, they found that their solution was the best. They also list a free and open source alternative that performs very similarly, so that's what we use. So thank you for that. So if you give it the HTML of this Reuters article, it will sort of spit out the text of the article. Nice. So Spacey you may have heard of before. Who's here heard of Spacey? Okay, so much more people have heard of Spacey than Chartbeat. That's okay. But Spacey, hopefully you all know, fantastic for NLP. They will give you NER pre-trained models. And sure enough, if you just plug the text from the prior library into Spacey, it will give you a fantastic list of all of the entities as well as sort of what type of entity it thinks it is. So you can see the first one, advanced micro devices, it thinks it's an organization. A bit further down, Lisa Sue, it thinks it's a person. And immediately there are a few problems with this. First of all, you can see several entities are sort of duplicated. So you can see AMD is listed a few times. It's listed under different names, so AMD and Advanced Micro Devices. Lisa Sue is referenced by sort of her full name, and then later on as just by her last name. The company that's being acquired, Xilinx, is referenced by Xilinx Incorporated, Xilinx, and this sort of odd stock ticker format that I'm not sure what the .o means. But there are many approaches to try and solve this problem. Many approaches to entity linking or sort of disambiguation. The first one I think is probably the most common is people try and use like these knowledge graphs. So Wikidata actually has an API for this. This is kind of like a weird form of SQL. If anyone's heard of Sparkle before, it's for like querying graph data. So you can say, sort of, give me all of the people where the name looks like Albert Einstein. And maybe you can include some information you're able to extract from the article, as well with that query to try and narrow it down. This is a little bit slow if you think about how big a knowledge graph can be and you think about the number of entities that may appear in sort of all news articles appearing across the news. Millions and millions of entities every day. If it takes 1 second to run this query, there's only so many seconds in a day, you're going to run behind. So that's a little bit slow. Embeddings, I'm sure, are very common. So if you try to make a vector that represents how that word is being used in the text. Interestingly, there's an open source library called Wikipedia2Vec that tries to vectorize sort of a word and then tries to find Wikipedia articles that have similar embeddings. So this is an example where if you try to get the word vector for Tesla and then find the Wikipedia articles that are most similar, you might find Nikola Tesla or the company Tesla. And so which of the two is it? So the idea is that you sort of include words that are used in the text as well to disambiguate it. So here you can see on the left you have Elon and Tesla, and if you try to get the Wikipedia vector that is closest to those two word vectors, you're able to sort of clearly get the company. And if you include bird, you get Nikola Tesla. Now, you might be confused. That's because this example is a few months old, before Elon tried to buy the bird company. So the guy, Nikola Tesla, was interested in pigeons. But that was not, I have jokes later on. That wasn't supposed to be one of the jokes, but it became, an anecdote moment leading up to this talk. Anyways, so the downside is that, one downside of this is that if the words are sort of totally unrelated and only make sense together, it performs particularly poorly. So new and York are words that really take on entirely different meanings when they're combined. You can think of it similarly with names, maybe like George Washington or something. George and Washington are a much different meaning than when combined. The other downside is that also, doing large vector lookups and comparisons, are particularly slow. We really found that we needed something much faster in order to try and run this on every entity in all of the news articles every day. And so one thing that is referenced a couple of times if you look up sort of the academic literature for this as sort of a very basic approach is to look at Wikipedia data. So this is the Wikipedia article for the Central Processing Unit, and it says many major vendors such as IBM, Intel, and AMD, and this text AMD here is a little hyperlink to the AMD Wikipedia article. And so, sure enough, this is an interesting example of all of the times that AMD is sort of the Wikipedia article is referenced as AMD. So there's actually another open source Python package called Pincho, and you may not know this, but it turns out Wikipedia dumps all of their databases online every 2 weeks at dumps.wikimedia.org, and you can go and download them. They're only about 50 gigabytes, and Pincho has made this Python package that will download it and process it into these nice little CSV files specifically for natural language processing tasks. So this is an example of the output of that library if you download it and run it. This is specifically a bunch of rows in the CSV having to do with Joe Biden. So it has sort of 3 rows here. The anchor text itself, so the text of that hyperlink, the target page ID, and the count. So you can see in the first row here it's saying that 6,366 times this page 145422 has been referenced with the text of Joe Biden. And you can see these are all the times that that one specific page has been referenced as that thing. And you can see sort of all the different names in natural prose that this Wikipedia page may be referenced as. So, you know, going back to this example with AMD, once you have this link to AMD's main Wikipedia page, you can also link it to the Wikidata knowledge graph. So this is the Wikidata entry for AMD. And one thing that's nice about this is that it also includes all of the known aliases for this entity. So it has AMD Advanced Micro Devices, you know, ones that are perhaps somewhat obvious, but also some that are not obvious, like Team Red. It would be much harder to find sort of via string matching or something. But if you're able to get all the known aliases for this Wikipedia page, that's very nice. This is Joe Biden's Wikidata entry. You can see there can sometimes be like a ton of different aliases for something, and you can go through and match all of them. So if you apply this technique to our Reuters article from earlier, you can see it sort of works pretty well. So up here at the top, we see Lisa Sue is sort of the base text, and one reference we find to it is Sue. And we have sort of marked down the different positions within the article. So the 111th word, the 155th word, the 239th word. Lower down, we have Xilinx as a reference, Xilinx Incorporated. We have the base text AMD and a reference, Advanced Micro Devices Incorporated. So it works pretty well. It's not always perfect. So just further down from this article, we have Taiwan Semiconductor Manufacturing Company. It's referenced as Co-Limited, and it turns out in its Wikidata entry, it's sort of spelled out Company Limited, and TSMC is not a known alias of that specific string of text. You could maybe do some kind of fuzzy string matching, but exact string matching doesn't totally play out. There's also this reference to Xilinx by what appears to be a stock ticker, but with .o. I'm actually not sure what that means. Maybe it's like .o if it's unlisted. We got some hedge fund people in here last night. What? Oh, .o means it's from the NASDAQ. It doesn't really follow. You'd think they'd have like .in or something. No. One would think they could have some kind of top-level domain system. I don't know. Maybe they could get a better registry. Another thing, this is the Wikipedia page for the Senate. This is the concept of a Senate. So oftentimes you might see things in the news that say something like the Senate today voted that, and maybe depending on the context, if you're reading an American thing, you might think, oh, well, it's referring to the United States Senate, or some Senate in the Eurozone or something. But it turns out Wikipedia, the most common Wikipedia article that's referred to as the Senate is the concept of a Senate, which is wrong in this context, not the end of the world. But the other thing is, this is the Wikipedia page for ideological bias. So it has this quote here: Wikipedia has an internal policy which states that articles must be written from a neutral point of view. I don't know if any of you guys have ever read the news before. Oftentimes news is not written from a neutral point of view. Oftentimes it has a strong opinion, and they'll reference people as sort of nicknames or derogatory names that aren't listed on their Wikipedia page. There are some times when it works fantastic, though. So this is some news article talking about college football projections, and it's able to catch the names of schools to references to their mascots. So the green wave, I think, is the name of, maybe not a mascot, but name of the sports team is a reference to Tulane, and Ohio State is the Buckeyes. What people call their sports team, I think. This is a tech conference, right? No one's going to call me out on that. So there is this other issue of trying to figure out which of these are actually important. So Spacey finds 36 entities in this article, 14 after you link them together. But this is a relatively short article. Some long articles may have hundreds or thousands of entities referenced. If you think about some like long news expose, might be talking about a whole bunch of different people and a whole bunch of different organizations. Some of them sort of only for a short moment. And for that, we use this algorithm called SK. This is the article that computer science professors wrote about it, and it's pretty interesting. So if you give it sort of the positions within the article of all of the entities, it will try to use how often they're referenced, how high up in the article or in the document they're referenced, and how close it is to sort of other important entities in order to figure out which ones are actually sort of important to the document itself. And so if you apply that again to our article here, A and B is sort of the score value is how important it is. So A and B gets a score of 152, Xilinx gets a score of 14, Lisa Su, the CEO of AMD, gets a score of 4, and ARM gets a score of 3. So here you can kind of quantify which of these things are actually important to the content of the article, and you can sort of figure out which ones are just referenced in passing. So this is the Wikipedia part of the pipeline. So we have a system that goes to the Wikipedia dumps, downloads them all, and then stores the results in S3. Interestingly, if you think about, what is a data set of all of the hyperlinks in Wikipedia and the number of times that a specific string of text is used, it's sort of less than 5 gigabytes with all the aliases. So it's small enough that you can just store it in RAM, load it as a data frame, and then just do data frame lookups. And it's very quick. So you can do it on a lot of entities on all of your news articles, if you're interested in doing that. Key terms are something else that we look at. So Chartbeat has a text processing library that was written by Dr. DeWild while he was at Chartbeat. And text-to-C, it calls itself NLP before and after Spacey. So one part of it is it has an implementation of the position rank algorithm that tries to pull what we call key terms out of an article. And so if you apply it to this article, it's able to not just sort of get entities, but sort of add some context to the terms. So we have not just sort of advanced micro devices, but the semiconductor designer, advanced micro devices, the CEO of AMD, a record chip industry deal, a Xilinx acquisition, and field programmable chip. So it's also November right now, and I want to be topical in this talk and demonstrate how key terms work. So I looked up some topical topics. So here we have real terms that were used by news agencies: pumpkin spice lattes, people who are pumpkin spice fans, people writing news articles about deep fried pumpkin spice lattes. Right now we're in the booming pumpkin spice season. There are people who are bona fide pumpkin spice experts writing about bad pumpkin spice products like pumpkin spice Ugg boots. Right. So moving on from key terms, there's these international groups for news agencies. IPTC is one of them, and they're really concerned about building these category schemes for pieces of content online. I believe it's mostly for selling ads. Like, people want to be able to sell their ads on articles about health and labor, but they don't want it to be on an article about sort of war or something. And so they spend a bunch of time building these sort of categorization schemes. And then news publishers will care sort of how many people are reading my articles about health, how many people are reading my articles about the environment. And so this is a pretty classic categorization problem if you think about sort of building a model that will predict whether or not a news article is in one category or another based on the text in it. I think the biggest problem for us here was, well, how are you going to get a whole bunch of labeled examples of these news articles just from scraping the text? So one thing we tried to do was we used Mechanical Turk, which maybe some of you have heard of, where you sort of pay people some amount of money via AWS to read a piece of text and then label it as one thing or another. We tried doing that. We ended up getting very poor quality data, people just kind of selecting one thing to move on to the next task. We tried Intern Turk, where you just have an intern sit down and label everything. This was terrible, mostly because I was an intern at the time. So I was just sitting there labeling everything. And it's really slow if you think about, how many pieces of text you need for your deep learning model. You might as well just have me sit there 24/7 labeling all of them as they're published. Can we use Wikipedia for that too? Turns out yes. So Wikipedia also has a news system called Wiki News, where they will publish news articles, summaries of news events. And they have a categorization scheme. It's not the same as the ones that other news publishers care about, but what's faster than labeling a bunch of articles, building a categorization mapping from Wikipedia categorization schemes to your own categorization scheme. And this tends to work pretty well for English. So this is a graph that's also stolen from Wikipedia, showing Wikipedia edits in various languages. So you can see at the top there in blue is English. It turns out almost half of Wikipedia edits are in English. So translation, you may have heard of. You can translate from one language into another. And a lot of cloud providers have paid services that will translate an article or sort of translate some document from some given language into another language. This is a photo of a Lamborghini. If you think about how much it costs to pay AWS or GCP to translate all of the news articles being published every month into English, it would cost about one of these every month, or about one of these pixelated images. But it is included in my talk for free, so I don't really know. One AFT joke. Okay, so Libre Translate is an open source project. They don't sell. They offer an API, sort of a prepackaged Docker image that serves an API endpoint where you give it some string of text and it will translate it into some given language. It's relatively slow off the bat, actually. It takes about 30 seconds for CPU-based translations. So when we were playing around with this, we actually noticed that it's powered under the hood by Argos Translate, which is another sort of open source package, which runs off of CTranslate 2. And CTranslate 2, interestingly, has GPU support. So this was kind of a cool chance for us at Chartbeat to jump in and do a small open source contribution to turn on and to enable GPU-based translations in Libre Translate. And it turns out doing it on GPU rather than CPU lowers the mean computation time in our testing from about 30 seconds to about 5 seconds. And so with that, this is an example of a Japanese article. I can't read Japanese, but if you plug it into Libre Translate and run it for 5 seconds on a GPU, it will spit out a curling final. Quick report, Japan x UK gold medal. The final of the Olympics, the first in Japan curling history. Curling women in Japan representative will play against the United Kingdom with gold medals. So, a little bit of a janky grammar. It's not the best translation, but it's just enough that if you train a machine learning model on Wiki News, it can look at that and say that's clearly sport. That was a big reveal. I was hoping for more of a reaction. So sure enough, back to our pipeline overview, we have the Libre Translate API in there that we can pull. So we have some Reuters article here, and in addition to just having the headline, we know sort of the body text, we know the key entities, which are AMD and Xilinx. We have some idea of the key terms, which are it's talking about this record industry deal, and we know the IPTC categories, economy, business, and finance. So a lot more of a complete view. With that, we export that out to S3, and then we load it via Snowpipe into Snowflake. And so what can you do with this data? This is a thing that we tried to do at the end of the year with The Economist. This is a graph of sort of the big news topics of the world by their readership and engagement. So you can see here in the bottom left side, you have, it's a little bit of small text. But sure enough, the bottom events are Capitol riot, Trump impeached again, and the Biden inauguration. And then you can see maybe if you sort of sift through, you can see your favorite news event during the 2021 news cycle. Yeah, all the way up to the news events that happened at the end of the year. Some lessons learned from building out this pipeline. Web data is incredibly unruly. I think if you think about doing something like test-driven development, maybe you heard that in your CS classes or something, you thought, okay, what's this data supposed to look like? I'm going to write some unit tests for processing data that's supposed to look like that. If you're trying to process web data, this will almost assuredly not work. The internet is like the Wild West. Anyone can do anything there. And if there's one thing they're not going to do, it's like follow spec. So lots of people will list their data in these metadata standards incorrectly. And if you write code that's used to process it correctly, it will sort of not work. So one thing we did was just look at the logs, read through all the errors, and then try to see how can we change our system such that it will work maximally and raise the fewest errors. Don't underestimate the power of a good heuristic. There are lots of machine learning solutions you can read about in academic literature for doing entity linking and disambiguation. In our experience, they sort of don't perform so much better than quick heuristics. They are sometimes wrong, but in general can provide okay performance for far less computational costs. And make sure to check open source offerings. Like, hopefully one thing you maybe took away from this talk is that there are lots of great open source projects out there. People have put fantastic things on GitHub, and you can use them in your pipelines to read news articles. And that's the end of my talk.
All right, thank you, John. Now we have time for questions, and I am going to hand you the mic. So I will come out with a mic. Why don't we start with you in the front, because it's close to me.
Thanks for the talk. Quick question just to verify, how are you doing the entity lookup? So you end up using Kensho that you described?
Yeah, so Kensho, I think they released like one preset version of all of Wikipedia process in 2019, but the Python code is all on GitHub. You can download it and run it to sort of get these CSVs as output. And the CSVs, if I sort of go back a couple of slides, and you remember like all the great jokes I told on all these slides, you know, one of them specifically is like the CSV output that is the anchor text, target page ID, and count. Once you have that target page ID, you can sort of do a join onto a mapping of the Wikipedia page IDs to Wikidata entries to get sort of all the known aliases for that page.
Yeah, and I wanted to jump to that slide precisely for my question. This one, yeah, leave it. So the Biden links to only one Wikipedia articles. Will it be a unique occurrence in this lookup table, right, or will it be
maybe I should have highlighted this more. So if you look up in the corner there, it says Joe Biden Q6279. That's the Wikipedia sort of index ID for this Wikidata item, and there is like an official. Where's the slide? So there is like a general Wikipedia page for Joe Biden, the person, and his ID, his Wikipedia page ID. You can look up how to go to Wikipedia page ID is 145422.
Yeah. So if I search Biden by this lookup, I will only find this 145422 and nothing else.
You will find other references.
Other references with the same Biden will. So you'll have multiple IDs for just Biden. Yeah. Right.
So you take the most common one, because I can go on Wikipedia right now and I can say, I don't know, any wild thing I want to say in my edit, but then say, you know, Joe Biden and link the Wikipedia page for something entirely unrelated. But in general, like the guess you want to go with is like 6,000 is higher than 1 or 5,000.
All right. Yeah. Thank you.
All right. Other questions? I'll come to you in the back.
So the Chartbeat slide, could you go back to that demo page? And I think a joke that you told that didn't get any credit was the headline examples. And I'm like really interested in, maybe you could read the third one out loud.
Oh, stay tuned for our concert live stream.
Or no, the fourth one. Sorry, the fourth one.
Oh, Olympic volleyball hopeful arrested for spiking punch. Oh, that's a good one. That's a good one. I also stole this from the marketing department. So I didn't realize that joke was there, but good for calling it out. Hopefully this is recorded, so hopefully someone at Chartbeat just watched that and they were like, wow, great job.
Did somebody just bump against the lights? Okay. Okay. That was a great question. How about you?
I'm interested in, have you done something on which is the main actor of the new? I mean, maybe a company is suing another company for some reason, and have you done something on which is the good part and the bad part or something like that?
That's a good question. We have not. My first reaction is, I wonder how many news articles are written specifically about like one entity taking an action on another entity. I feel like there's probably a lot that are, I don't know, I'm trying to think maybe more like general in nature, but it's very possible. That's probably a good idea for something we could do to try and
Sorry. Were you able to use the out-of-box spacing models, or did you have to do any training to improve entities or entity recognition?
Yeah, so we use the out-of-box like spacey NER models. The categorization thing I talked about was us training a text categorization model. So that was the sort of retraining we had to do.
I was curious about your entity disambiguation and resolution in different languages. So what happens there? Are you able to source that? Does that come from Wikipedia?
Right, yeah, so there are other like language Wikipedias. The downside is that they're far more sparse. You can still do NER via Spacey. Spacey, I think, supports something like, I want to say 22 languages or something. It's quite big. You can't use like English Wikipedia data to disambiguate it. We have looked a little bit about like, well, maybe we can use that language's Wikipedia for it. But I think it's a bit harder because there's not as strong as a signal in the data.
Any other questions?
Thank you. It's a great talk. So I just have a question. Like, if you do NER, have you thought about like reducing the scope for the NER? For example, for sports, if you identify this article is about sports, and then the entity will be much less, and then you will have much better precision on the NER. Have you done that kind of like a categorized NER?
That's a good point. We have not specifically done that. Maybe not specifically with scope on like towards categorization, but one thing we were really concerned about and we wanted to step away from is even in cases where we might be able to leverage sort of like other perhaps like use of how an entity is referenced in a news article. We try to stay away from it because there's a lot of risk if you sort of are able to reference it to something that's sort of like completely wrong. So I'm trying to think of an example of like, maybe there's someone named Tom that's being referenced a lot by sort of some news agency or something. If you say, well, this news article is writing a lot about Tom, it might be this one as well. Well, it's much more likely that outside of the scope of a single news article, there's a lot more entities named Tom. So your need for disambiguation as you move to like a scope level, I think expands significantly. That makes sense.
Great. Any more questions? I have a question, actually. It's more of a business question. Can you use this to like collate by topic and then share with each publisher's competitors?
That's a good question. So I think that like ownership of this data is very important. So I think that they maintain ownership of this data and we sort of show it to them. My understanding is that there's significant need, like every news publisher wants to say like, well, how am I doing compared to my competitors? And they'll sort of like name their competitors. But then if you say, okay, that's cool, tell you what, if we put the 5 of you together and we'll all show you each other's data, they'll say, well, no, you can't show my data, but show me their data. And so I think there's maybe like a little bit of a chicken or the egg thing. But